In this lesson, you're going to learn how to convert numbers from standard notation into scientific notation and vice versa. So we're going to start with the number 1,487,914,000. That number is said to be in standard notation, or standard form is another way to say that. Now I'm going to take that exact same number and I'm going to write it in scientific notation. You'll learn how to do this in just a moment. But in scientific notation, that number would be 1.487914 times 10 to the 9th power. Now we're going to learn how to do that, but remember from our previous video, the first number is between 1 and 10. We multiply by 10 to a power, and the exponent is an integer. So this is in fact in scientific notation. Another number that we're going to have is 0.0046. That is a number that is in standard form. So standard form is what you would normally see numbers written as. We're going to take that and we're going to write that in scientific notation. So that would be 4.6 times 10 to the negative third. So if we look at the rules, the first number is between 1 and 10. We are multiplying by a power of 10, and the exponent is an integer. So this is in scientific notation. So let's go ahead and learn how to do that. To convert from standard notation or standard form to scientific notation, we're going to move the decimal point so that the number is greater than or equal to 1, but less than 10. So in this example of 5,302,000,000, we want to move the decimal point so that the number becomes in between 1 and 10. So in this example, I'm going to want the decimal point to be right after the 5. So we put the decimal after the first non-zero digit. 5 is not a 0, so we put it right after that number. That's where we want our decimal point. Now if I take a look at the other example, I want to put the decimal point after the first non-zero digit. So I want my decimal point to be right in there. It's after the 1, which is the first non-zero digit. Alright, the second step is if the absolute value of the number in standard notation is greater than 1, the exponent will be positive when you write it in scientific notation. So you can see that this number here is greater than 1. The original number is greater than 1. So we're going to have a positive exponent. So I'm going to write that here. Since this number is greater than 1, we know that there's going to be a positive exponent. If the absolute value of the number in standard notation is between 0 and 1, the exponent will be negative when you write it in scientific notation. So you can see with this number is between 0 and 1, so we know we're going to have a negative exponent when we write it in scientific notation. Okay. The third thing that we're going to do is we're going to look at the value of the exponent, or find the value of the exponent. That will always be equal to the number of decimal places you move the decimal point. So let's take a look at this number, again, the 5,302,000,000. So I'm going to take that number, I'm going to put the decimal point where it goes right after the 5, so that my number is now between between 1 and 10. So it's 5.302. We know we have to multiply by a power of 10, so times 10. And the exponent is how many times I move the decimal point. Now what you need to know is that in the original problem, you didn't see a decimal point. When that happens, the decimal point is always at the very end. So we took this decimal point that existed before at the very end, and we moved it 3, 6, 9 spaces. So my exponent has to be 9. So that means it's a 9 there, and then I'm going to come back up here. Remember that it was a positive exponent because the original number was greater than 1. So this is the number written in scientific notation. Let's take a look at this one here. So we're going to put the decimal point after the first non-zero digit, which is right there in between the 1 and the 4. So the decimal point goes there. You can see where it was originally, right there. So I have to move it 1, 2, 3, 4, 5 times. So since I moved the decimal point 5 times, the exponent has to have a 5 in it. Now, if I come back up here, I wrote down that I had to have a negative exponent, and that's because my original problem was between 0 and 1. So since this is between 0 and 1, my exponent has to be negative, so that means the exponent should really be negative 5. So I'm ready to write the answer. The first number has to be between 1 and 10, so that's why I put the decimal after the first non-zero number. So it's 1.4. We're going to multiply by 10 to a power, and the exponent we just wrote down up there was negative 5. So this is my answer, 1.4 times 10 to the negative 5th power.